More vectors, math vectors, so you'll like them better. Math vectors, so vectors with math, we're going to do the algebra with them and see how we're doing with that. Oh, well, if you hand it back to me, I will check it out for you. If you hand them back to me, maybe I missed them. Soon. Okay.
I get home, my dad had to do homework, and he's like, "Did you do it Sunday night when we're not setting up at the lake?" And then I fell asleep with the computer on. Now, our electrician had to fix the electricity in the garage because apparently whoever did it first, it started to arc. You know, the white wire did. They didn't do it right, and it almost burnt the whole place down. They had to cut it. Yeah, but it's good now.
So that's where my wiring is right now. So it's not even in the trench to the house yet. And this great rocks. So
Those are very nice rocks.
you could have a whole bunch of these for flags around the patio and around the fire pit. And now, this whole, your success here with vectors is based on your being able to use a triangle, to set it on a coordinate system, XY coordinates. And there are numerous ways that this is done in most cases. So you are free to arrange it however it makes the best sense to you, so long as it's correct. Okay? So there can be more than one way. In other words, you could arrange it one way and use cosine to find the part of the unit, or you could arrange it another way and use sine, which is sine is the opposite of this. Many times in your trigonometric relationship, I should probably write correctly that we're not those wacko. Yeah, I taught math the first 4 years of my life, along with some science.
You taught the first 4 years of your life?
First 4 years of my educational life, yes.
Oh, that says E, not C.
Yeah, when I was hired at Fairlawn for my first teaching job, oh dear God, they said, you know, we need a math teacher too. We noticed that you only need 2 more classes in math, and you could get your math straight. And also started math 7 to 12. And I said, really? And they said, here, you can take them. You can take them and have online classes back then because no one had computers to teach. So it was a correspondence course. I had to write assignments and mail them off. And the only 2 courses I could find that Ohio's requirements, because I was working in school, they didn't offer anything at Lake Campus or anywhere that were differential equations and nonlinear geometry. So differential equations, after I hadn't seen calculus in 10 years, that was fun. And in non-Euclidean geometry, you learn that 2 parallel lines can in fact be proved to intersect. Now there's a useful life skill for you.
I bet you use it all the time.
I do. I use it to make a joke about math when I talk to physics students. So you can, when you have this thing that's moving in a certain direction, you're going to set it up on an XY coordinate system. And you can set it up any way that it's making sense to you as long as you find it and work with it correctly. There will be more than one way. There are some ways that are easier you'll find as you do this. It is usually easiest to set them up on an XY coordinate system like this, because then if something changes, it's easier to make that change. You know, you can make the Y be north and south and the X be east and west. And it's easier to define the change.
I'm really talking to Lucy the other day. I said, I'm always on time.
Because you have like a 10-minute break between your class and lunch.
That's a
So,
Thanks. It was $460. $60. Club brand. It's from a YouTuber.
so you have an example of this on page 93 of your book. And we can just kind of look at that guy where we'll walk through what they're defining. Because when you walk through them by yourself, you tend to just kind of go, yeah, I see that picture, but I don't know what it means. Yes.
There's two. You need one? You know what I need more than a charger? Your notebook? Notebook. I shall observe.
Not book or book.
You can write this down.
Oh, you're writing up there?
I'm going to work it up here for you.
Okay. What page number is that?
It's 93. People maybe wanted to look at this as we work through
Will we be
this.
turning in stuff from page 93?
We'll be turning this stuff from page 94.
Okay.
The first 4 problems probably that you'll sweat your way through today and whine a lot.
We're not using the protractor. I'm okay.
We're not. You're not. You get to do math. Okay. Okay.
Me and not like that. Yeah, but Riley, you were crying and running between both tables trying to figure out how to do it.
So we have this hiker who is going to go 27 kilometers from her base camp at 35 degrees south of east. So to put that on a coordinate system, I would do this, and you don't have to worry about making them to scale. Really, it's helpful if you kind of draw them to stay on scale because you can see them better, but you have to measure them. You're just going to guesstimate and you're going to calculate. So we're going to, we'll make this Y, we'll make this X. And to keep this easy, we're going to put base camp right here. Right there, really, we are. Okay, there's your base camp. So she's going to go 27 kilometers at 35 degrees south of east. So if we say that this is east and this is south, she's going to go 35 degrees south of east. So that's going to be a little bit closer to east than to south. Maybe I can draw that.
Closer to east, closer to south.
Because this says 35 degrees south. So if this is south and this is east, if you're going to go east, 35 degrees south of east is going to be south of east.
Okay.
So you're going to read the problem in what? Why? You already knew that. Yay! See, calculus is your friend. It is. And then this would be 35 degrees. We'll label it theta 1. Okay. The next day she walks 41 kilometers in a direction 65 degrees north of east.
Why physics is science when I think we should call it environmental math?
Applied math is really what most of it is. It's all the math that you learn to do with the reason behind it. Yeah.
It's just like the principles of science. But
It's applied math. You're applying math to
Yeah, I
scientific.
it's just me, I think it should be that.
Okay, so good. Then we're doing that.
Which
Okay,
makes me
so-
mad. I like science.
Then we want to go 65 north of east. So here's our east. Here's our east. Going this way. And we're going to go, so how will I draw that? What? Closer to 90. So this we said was 35. Okay, so we're going to go 65 north of east.
Oh,
So
northeast?
we're gonna go in the north direction, but we're gonna be north and east. We're gonna be up here, north and east. So how will that line look?
It'll be probably in the third sector. So like three on one. Oh wait, because it goes this way, doesn't it?
So she's walking 41 kilometers. It goes which way? Yeah. So she's walking in, if she's walking, this was 27 kilometers, 0.0 kilometers, sorry. And if she's going to go 41 kilometers, it's going to be farther. It's going to be a longer line than this. So it's going to cross this, the x-axis. East. Yeah. So does that look like about, no, probably not. Does that look like about 65 degrees?
Yeah.
All right.
Oh, we're just doing like piecewise functions now.
Like what function?
Piecewise. Piecewise? Why are you looking like a maniac?
Because you don't have your mask over your nose. It's where you what? Go ahead, Grady. Oh, okay.
That's all this is.
Okay. Okay, so yes, you're putting a bunch of different, they're not really functions, they're just vectors that you're adding together. So we want to know where magnitude and direction of her resultant displacement. So here is her resultant displacement from base camp. Okay. So now what you know is that this is 65 degrees, right? Okay. So what else do you know about these other angles? Length of an angle.
Of the line that is making the angle. Oh, I didn't you tell me.
Okay. Well, we know this line, if I drew it correctly, okay, we know that this angle would also be 65 degrees, right? Okay.
Does that time we need to add up to 180 degrees? That
Yeah, but we don't know.
I see what you're doing here.
Really? Yes. Yes.
No, I don't like the way it's going.
Okay, so going back to basic geometry, if we have this line, which I can't make be, yeah. And so we have an angle here. This angle is 35 degrees. And this is a line. What do we know about any of these other angles? We know this is 65. What do you know about any of these other angles? If this is 35, what do you know about any of these other angles? This, which one? This one? This is 35. Why?
Where's that guy? Adjacent.
Bless you. I think that would be an opposite interior angle. Okay. So you know that this angle is going to be 35. What else do you know?
The other angle, those two have to add up to 65, right?
So if we know that this angle is 65 and this angle is 35, does this have to be? What we're looking for is a 90-degree angle somewhere. Any ideas? Are you doing that just because it looks like it's 90 degrees? Or- Okay.
Well, does it need to be 90 degrees?
Well, if it is, we could use the Pythagorean theorem. If it isn't, what do we have to do? Okay, so how might we do that with what you know here? We're looking, remember, for the little red dashed line. That's the resultant. So we're looking for her displacement, which is how far did she end up from where she started, not how far did she actually walk. So you want magnitude and direction. So you need a distance, you need a meters or kilometers. Because you walked, yeah, kilometers, and you need what angle this is. So we want to find the resultant, and we want to find this angle. So
Given that it's gonna be northeast,
we do
and that's all I can figure.
right now. So we know that it's going to be some kilometers northeast and some degrees northeast. So what do we know? What can you do with this?
I'm still a little confused on how that would be a 35-degree angle. Because
Okay, I'm not sure it's actually important to this problem. There are other ways to do that.
okay,
Because it would be parallel, because I drew this line parallel to the x-axis. So this line would intersect it at the same angle.
okay.
I was making a point rather than showing you something that might be useful. So what you need to do is you need to arrange these things in a way that you know a side and an angle, and then you can find the other sides and angles using your trigonometric functions, yes? So let's play with that a little bit and see where you go. The book tended to write all this out in a much more complex way than you need to do. You figure this out, come on. With your mask over your nose, because God knows where you were last week. Well, this is a picture of this problem that you're working. So what you want to find is the x number and the y number for each of these vectors. So for this guy right here, you want to find out what its x value is and what its y value is. So you know 35 degrees, right? And you know its hypotenuse. So you want to find out what this is, and you want to find out what this is for this. Then you want to find the same things for this vector. You want to find out its x component, and you want to find out its y component. So your goal with every problem like this is to find the x and y values. We want the length of the line. So you're going to use your trig functions to find the length of the line. Okay, that's this line. You want to find the length of x and the length of y. You have a hypotenuse. What no?
We only have one. We only have the hypotenuse. We don't know in the angle of it. We need one more because it could either be like opposite hypotenuse, adjacent hypotenuse, or opposite over adjacent. So we need one more. But we don't have it.
more.
Okay, so this is the I'm the real question. What are we trying to find? Like, what's the triangle look like? Like, where is it at?
So we could make a triangle. We can make a triangle from this guy, right? This is what you were told.
Yeah.
So, and you know that it's 27, this is the hypotenuse. And you know that this angle is 35. So how would you find the, let's say, how would you find the adjacent? Which of the other sides is adjacent? If you have this and this, what's the adjacent side?
You're looking at the hypotenuse, what angle is it, 35 right?
Mhm.
So it would be the x-axis.
Okay, so we want to find this. Okay, so that would be the adjacent. So what trig function do you use to find the adjacent? If you know an angle and you have the hypotenuse. You're
Cosine,
looking,
you would rearrange it, right?
cosine equals adjacent over hypotenuse.
Cosine of 35 equals,
So you're going to have cosine of theta times the hypotenuse equals adjacent, right? And that will give you the x coordinate.
Opposite exterior angles add up to 180 something like that.
Opposite exterior angles, yes.
We know that big angle there, the obtuse angle, is 135.
Which one? Yes.
No, up.
Yes.
Yeah, there it
This
is.
one?
Yep,
Okay. So you think that's going to be 135?
I think so.
Well, 125. Yeah.
Right. Okay.
125.
I got 22.
Then 145. We were all wrong.
115.
We're adding up to 180.
Anyways, the cosine of theta, which would be
35
cosine of
plus
35 multiplied by half the
145.
hypotenuse. I got 22.
That's 65.
Wait, you got what?
22 point, you just need 22, right? Just need 22?
So we have what, the cosine of 35?
Yep, multiplied by 27, which is the hypotenuse.
Those are the ones that add up. What do you give me that look for?
Would be 22. Also, it's kilometers.
Oh, that does add up with that, doesn't it? Yeah.
Wait.
So it is 115.
Okay.
We know that's 115.
Would be 22.
So what you're saying then
It never reacted.
is you're saying that the x coordinate, which is right here, is 22 kilometers.
I did cosine of 35 multiplied by 27.
I'm going with 22. Are you in degrees or radians? Radians would be way screwed.
I understand what we're doing there.
Okay, then do it. Then find another one. You want to find the components. You want to find the component. You want to find the x and y of every triangle that we made here. If you can narrow it down to the triangles that will be actually useful, that's a plus because you'll do less work. Because if we find, we now know that from her trip, we now know that the 22 kilometers was here. We need to find this much more and add them together, right, to get the total x. Then we need to find the y from here, and we need to find the y from here and add them together to get the y. So if this is correct, we have found one of them. We need to find this now. So how will we do that? We have 65. Where's the hypotenuse? We have a hypotenuse for this.
No.
Okay, let's play with a few things and try them and see how they work out. Try a few things. Try a few things. Find the X and Y for some of the triangles that you have found there.
Okay, let's see. 41.
So you found, for this triangle that we were working on so far, you found the adjacent. All you have to do is find the opposite, which means I'll use the sine function to find the opposite. Okay, so for this triangle, for this triangle, you know the hypotenuse, you found the adjacent, you need to
Oh, we
find
know
the
that one's 65.
opposite. Okay, so you can use the same value, except you're going to find sine. Okay, and that's going to tell you,
I got 15 for that. That will tell you that? How would that tell you that?
and technically it's a negative 15 because it's going down.
Wait, how did it tell you that?
The sine of 35, because here's your triangle. Okay,
Mhm.
here's your angle, and here is your hypotenuse that you knew. You use those to find this. Now you're finding this. Okay, this,
Yeah, what is on the opposite?
oh, over here?
Yeah, what is that?
That's opposite.
Why?
Because sine is opposite over hypotenuse. And if you want to find
Okay,
the hypotenuse-
And what you're finding is actually then going to be this, right? Here's your 90 degrees. Okay,
Doesn't make sense, but okay, yes.
because we made a 90-degree triangle out of
I
this.
thought we were just doing that.
So you have 35, you have 65. Okay,
Okay, sure, I guess.
so I'm making a mess of this.
This is where with any other geometry except for circles, you can't do circles. But 35, 65.
Don't have up to that. Yeah,
That's where we run into an issue, huh?
What's the issue?
the issue is that they don't add up, so we do not draw the triangle, or you're not looking at the correct triangle. So if we have 35 degrees here,
So it's not.
we have 35 degrees. If we drop a perpendicular here that we pretend is going to be 90 here, we make this 90. Okay. Okay. If you still use the hypotenuse and the 35, you can find this distance, yes, whether it's 90 degrees or not. Right? Yes? Okay, this is just a simple triangle. You've got 27.
So could we just do an A squared, B squared, C squared thingy? Is this the right triangle?
No, we don't know that.
But you made a line straight down.
Try it and see.
Oh,
Huh?
Try a squared plus b squared equals c squared and see if you get. Now that you could, we knew this, we found this.
No, she said 15 doesn't work. It doesn't make sense. How does 15 not work?
15 works.
Then what's not working?
Nothing's not working.
this is a long drawn out process.
I've heard
Well,
someone
it's a
say,
couple of steps.
couple, 100.
There are 4 steps to this. Once you draw, the first step is to draw your basic thing, then there are 4 things you have to find.
The steps like our homework was the question 4. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V.
Literally.
Do you understand this triangle?
Yeah.
Okay,
I understand that. I just
So-
don't understand what we do with it.
Well, we can take the 27. We can find the square root of 27. Then square root of 22, and then we'll find the difference.
so
Right, correct?
what you want to find is you want to find, you've got 2 triangles here that you made from both of her trips.
Wait, but Mrs. Lee, that's not 22 kilometers, because look where we cut it off at.
That's why you can't
Oh,
use
okay.
the 22 again, that's why you're using the 27.
But I thought we used 20, and we used the 27 to 22.
He does, poor guy, he does,
Does he get it?
Hi, Josh.
yes.
I'm glad he gets it.
Josh is.
How does Josh get it? What is Josh doing over there?
Okay, okay. So what did we draw here? Now watch, you can either whine or you can learn, you got a
I'm trying to
choice.
learn, I just don't.
Okay, let's do this again with your mask over your nose, thank you. Here's a base, right? And then she walked what?
27 kilometers southeast.
Approximately is what I drew there, okay? You can do this with a ruler and a protractor if you'd rather.
I would not rather.
Okay, okay. So
Would it make it easier?
we're approximating. So
No.
I would just kind of guesstimate those lengths, make one longer and shorter, and yeah. So, and this angle is what?
35.
Okay, so if we take only this part of her journey, we want to find what is the x coordinate of this. We want to find how far did she go on the x and how far did she go on the y. Okay. Then we're going to,
22 and 15.
and do you see how we got those numbers?
We did cosine
Oh.
and sine.
Oh, yeah, use cosine to find which one.
And
Is that making more sense?
Yeah, it was just all the stuff there was just like.
Yeah, that's why we
Mrs.
do
Lee,
it.
I zoned out.
Oh, well. So once you find this x and this y, then you draw the other one, which I would draw on the same one, but it was a lot of stuff, so I won't. Okay. Then she went from where to where?
we went from that point north.
Okay, can I just draw it over here in a different color? Because I don't know that I'll be able to, all right. I don't know that I will be able to. So she went from here to where?
North in 41 kilometers. Yep.
I'll stop doing this. So is that about 65 or no?
Yeah, I think that's good.
Is that good? Well, she went 41 or something, didn't she? Yeah, 41. Okay, so now what you have to find is you have to find the x and y coordinates of this as well. So you have to and we know, what do we know is 65?
So could we do cosine of 65 to find the x?
It's not 90 degrees.
It doesn't matter
Okay.
with this. Okay, so what we need to find now is we need to find the x and y for this. And we know this is 41, but we've got,
So it'd be cosine 65 multiplied by 41 kilometers.
Really, aren't we looking for the displacement? Like,
we're looking for,
I got 17.
we're looking for this.
But we
Or this
can't-
place.
But we can't choose the Pythagorean theorem, it's not a right.
Right, right,
Okay, so
right.
I got 17. Oh, no, this is right.
yeah,
For
that's not the
what?
hypothesis.
No, I used cosine 65.
So we are now trying to find
That's
from this triangle here, okay, from this triangle. Don't panic, it's here somewhere. She says that she doesn't panic. Okay, where can we put this triangle on an XY coordinate system? We need to draw an X and a Y for the triangle this triangle. What did you get the 17 for?
I did the cosine of 65 multiplied by 41.
But can you,
So that found the X or the Y,
So I found the x.
okay? And we think that that's right.
It doesn't seem right, so maybe you should add 15 to it.
What did you find for it?
17.
Yeah, that's right.
That's right for the whole thing. You don't.
No, it's right for just that part. So this part was 17 the X or the Y. What does your book have for that? By golly, it does. So we found the first X as being 22. And then we found this X as being what?
17.
Okay, so we found these. Now you have to do is find the Y's using signs. For the Y, the Y's will be signs. The X's you found using cosines and the Y's you found using signs. So the Y, you would use the 41 and sine of 65. And so you'll find these two Y's. Okay, so you'll find these two Y's. You have your two X's. Book had 39, but probably in rounding.
I got 37.
Oh, okay, I see where you are. You're on the day 2 one. Yeah, so now you know that you have here, you have a right angle, right, between the X's and the Y's. So the total, the Y's were what now? What did you get for each of the Y's? Okay, and what did you get for the X's? 22 and 17. So now you have a right triangle that you know the total of the two sides, right?
Wait, could the right triangle be like this?
Yes, it could be, yes, yes, yes.
Wait, couldn't we just do 37
Yeah,
and then the 22 plus 17 on the bottom and find the hypotenuse?
try it and see. Except I'm not seeing that this kind of came out right. You have Y 15 and 37. So when you deal with this,
53.
when you deal with this, you've got 37 plus minus 15, right? And that equals what? And over here, you have 22 plus 17, and that equals 39. Okay, so did you use those in your Pythagorean theorem?
Well, let's see this
squared plus
for the 37.
39
Yeah.
squared.
Because you're going from the camp.
Square root of those.
So you want to leave this out?
The 15 out because you're leaving from the camp, so you're trying to find the bounded hypotenuse. You
okay.
use 37 as
Okay,
an A,
And
and then
what-
39 as the B.
what did you come up with?
53.
You should be coming up with 45. So
I could have also done my math wrong.
what isn't okay? Okay, what isn't okay? Okay, if you take a look at the way that this has worked, now that you have some numbers on in section 2 where they found the components of the vectors, they have a lot of crap in there, but you can see that they did to find x1, which they called from day 1, they did 27 times the cosine of negative 35, they got 22 and 15, just like you did, okay, for x and y, only I labeled these wrong.
Why would it be 39 and 20?
Well, look at what they did. They had 22 kilometers for the two x's, 22 and 17 for the two x parts, like you had right here. Here's the 22 and the 17. So that was 39 for the x component. And then for the y one, they did the 37 and subtracted this 22 that you found.
Because that wouldn't be the hypotenuse they're finding though.
So,
It's not like I get that.
so let me see if I understand what you're saying. Well, you're saying that this would not, hypotenuse would not be the same as this one.
No, I'm saying it would. I'm saying that the whole 37 and the hypotenuse and the 39. Why did they subtract 15?
Because she went this direction and then turned around.
We're just trying to find displacement.
And
right?
so, right, and displacement is just the distance from here to here. So everything she went down here doesn't count, and that's this y1.
So wouldn't you just go up 37 and then over 35?
Yeah.
Yes,
Then why doesn't it work?
but 37 is the total of this. Where did this 37 come from?
Oh, okay.
37 was the total. You only want this much of this. You had
So
20.
sine of 65 times 40 is the whole.
Is the whole thing
Yes.
not just the other triangle?
You don't want this part
Oh my goodness.
because she backtracked
I'm
here.
sorry about this book.
I feel like it's been overthought.
Yeah, it is. We have a thought.
So it's 45.
I would have been good, I just don't know.
Yes, so you should get 45. And you got 45 to be clear by doing,
I didn't realize that 37 was the whole.
I did the Pythagorean theorem, but like I
Okay,
did
yeah,
the
37. 37 is the whole thing.
I thought 37 was just the top.
Yeah, that's what I.
No.
Okay.
I got plenty of scheme on it.
Okay, so now that you have done the problem from hell and we've worked through that together, you should find 1 through 4, at least 1 and 2, to be way more simple than this if you can get the picture of what they're doing correct. Okay, 3 has a couple more steps in it than they did, but the trick with 1 through 4 is in number 1 with the football player, and I did this the first time I looked at it. The football player is little player is running down the field, so I made that go down. Okay, and then it says for 35, before he turns to the right at an angle of 25 degrees from his original direction. It is not this, it is 25 degrees this way. Okay, so here's your 25 degrees. Right. So then what you're trying to find is this whole distance. So what you really need to find here is just this and add it to the original distance that he ran straight. So these triangles are much simpler than the god awful one they gave you as an example here. Well, he ran 35 and then he ran. So all you're finding is this additional piece. We'll call it y since it's going down. And then you're adding it to the 35 is all you're doing. So take the, what? Freezing? Oh, good. I'm freezing, but the windows are staying open, so there's that.
I've been over.
So when you work these problems, which I expect you to come in tomorrow and not whine about them, just do them. Questions are good. Questions are good. So read the question and make sure that your picture is reasonable first. Make sure that you totally understand what you're drawing.
So is it page 94, 1 through 4?
Yeah, there's some section review there too, but we're just going to look at the problems. Okay.
Here we go.
We'll be fine. On video.
I'm gonna stay in this class.